This video is going to help you learn about remote sensing with cloud-based resources. It complements our textbook that was published in April of 2020. And after we look at these amazing new technologies, I want to ensure that you take time to check to see if the streaming map or the map that's displayed on the cloud-based platform is accurate. So first we're going to look at Sentinelhub in the EO Browser. It's a complete archive of numerous remote sensing data. This is an example of what we're going to look at in the EO Browser, an area in West Africa with the kind of enhancements that's provided instantaneously just about. It's remarkable. But first you should log in so that you have all the benefits of this Sentinelhub EO Browser. And if you want to learn more about EO Browser, which I strongly encourage you to do, there's a series of videos by the group that built the Sentinelhub EO Browser, ArcGIS. I just have a few slides describing them. They're based out of Slovenia, very talented group. You can see the different focuses that they have on their web page. This is the Sentinelhub that they built and their new offerings. And what happened is Planet, which is a very large commercial satellite company, bought Synergy's business. And now they have this Sentinelhub, and they're using it for their Planet Insights platform. So what we're going to do is look at the EO Browser. You can see that I'm logged in. I'll go back to Discover. We're looking at an area, and I've been working on this area, so there'll be some examples already discovered. First we'll look at Sentinel-2, which is a remarkable satellite. You say, well, what's Sentinel-2? And you can get information by just clicking on the question marks. And if we do an advanced search, we can minimize the cloud cover. And what I'm going to do is, what I've discovered is, you scroll down and then you see the time range. So I'm going from December of 2023 to January 31st of 2024. And you have to use the scroll down to see the calendars. Now we're going to search. It works very fast, and you can see right now there's a little delay in the thumbnails being displayed, but I know the 28th of December is a good image. You can see it comes across pretty dark, but we have these tools, show effects and advanced options. And so I can just increase the gain a little bit and maybe increase the gamma. And I've got a really good natural color. And you can see we've got a stream coming through here, different kinds of vegetation, some buildings going on, some development, some canals or dredged channels. I go back to this icon. I can display this also as a false color. And again, we've got our reset it, and there's the false color. So the brighter shades of red are the more vigorous vegetation. You can see the textures and the color. You're seeing these interesting features here. You see them here. And then over here you see other features that have a very smooth tone, texture, and then a difference. So you can see with your eye, you're interpreting what this vegetation cover. And then we've got NDVI, which is normalized difference, so you can see very vigorous vegetation. So you have all these different renditions of the imagery, along with a scene classification map. So you can see it has a lot of water. That's water is blue, vegetation's green, and not vegetation is what this algorithm is telling us. It's according a result of ESA's scene classification algorithm. So that's what I want to warn you about, that when we look at the image itself, in fact, what we can do, let's see if I can save this as a pin, this image. They have these different tools, and I'm going to pin it. And now I've got the classification here, and I go back to visualize, and I want to compare it to, say, the true color that I enhance. So I'll go and enhance this true color. That was a little too much. See how fast this is performing, and I'm not using a PC or anything. It's just looking on the internet. It's amazing. That's the only word for it. And I'm going to pin this now, so you can see the true color I made, and I want to compare these two. So I go to this, put it into compare, put this one into compare. I click on the compare. You can see I've been doing a lot of work here looking at these different ones, but this is what I want to do, is compare the algorithm derived land cover map with the image. And so you have a slider, and see if you agree. It's saying out here there's a tremendous amount of water. Doesn't look like water to me. So right off the bat, it's missing the developed. Just be careful when you say, okay, I'm going to use this map for my work, because it's not looking so good. And I've got a color infrared that I processed before, and I'll turn off the true color. Which one's on? Let's turn this one off. This one. This one's on all the way. There. So you can see there's a real problem here, that we have the same tone here and here, but on our classification map it's got it as two different classes. So let's go back to Discover, back to Search, and we'll bring in a radar. This is truly amazing, that the advanced search, we've got our range of time, but it doesn't really matter because the radar's all weather. And you can see sometimes it's upside down. It depends on which way the satellite's moving, north to south, south to north. And I'm going to turn on the grayscale. And this does an excellent job of showing where there's water, very clean boundary where there's water. These dark areas, the radar's bouncing off the water surface. And then we can pin this again. Now it's back into our pins. We can go to compare that with, say, the true color. Go up to compare. So you see how clearly the radar captures water. So it's excellent for making a map. And the quality of the radar processing is exceptional. So you should actually read up a white paper, what they're doing with their Sentinel-1. We'll go back to Discover. And what's really interesting is you can go back in time. So here I go back to Landsat. I'll say I don't want much cloud cover. And then you have to scroll down. And I'm going to go back. See, I'll start at like 1982. And we can make it January 1st. You have to keep scrolling down. It took me a while to realize that was the game. And we'll just take it up to, say, 1987 and hope that there's some images in there. We'll take it to September. Searching that fast, and I'm having some issues with streaming the little thumbnails, but you can see the cloud cover. We've got a really good image here with no cloud cover. Once again, we can highlight this. It's hazy. Natural color is hazy. But let's try a color infrared. And we'll go back to visualize, false color, and you'll see it's much sharper than the natural color because a little longer wavelength, getting around the haze in the area. So I've got this 1986 image, and now I can go and pin it, and I can say, okay, I want to compare a 1986 to a 2023. So we're looking at almost 4 decades difference. I've got my compare up here. It's at the top of the list. So on top is 2023 and bottom is 1986. See, the area is actually quite stable for some of the vegetation types that we're seeing. I can't move the cursor without, so I can't point things out. So when I come across in 1986, you'll see these textures that we'll look at a little later in Esri, ArcGIS Pro, and we'll see what happened down in the bottom part. You can see down in here there's been some degradation in that vegetation coverage. But a lot of areas are very similar over 40 years. And you can see construction going on, development, some of these linear lines, those aren't natural. But the streams are amazingly stable. Now what I can do is go back to Discover and go back to Search. So down here at the bottom you can see Planet, which now owns Sentinelhub. NICFI, what's that? It's the Norway's International Climate and Forest Initiative. So if you're a researcher, perhaps if you're a student, you can sign up and use the data from Planet. You can't use it as a commercial venture. You have to pay money, but it's really for agriculture. So I'll just show what it looks like. So the Planet, we'll go down and we'll say search. These are base maps. So I'll pick the one where I know there's not many clouds based on previous work. And this is a higher resolution, 5 meter pixels. You can see the area very clearly shows up. And we've got a color infrared version also. So you reset and it's really good, and you can compare this. So let's go back to the radar, Sentinel-1. We'll go to very recent imagery. And we'll put on the showing clearly the water. And what you can do is download. So let's say that I want to download this into my GIS. I'm able to download a JPEG or this analytical tool, and I can download a TIFF. This is only a black and white 8. I can download it as large, so it'll be 7 meters per pixel. It's a preview. Oh, instead of the web creator, I want to go UTM. I'm working in a GIS. And so I'm downloading this radar. Radar is very difficult to work with, so this is a real service to have the Sentinel-1 available. And there it is, and I'll just drag it into my folder and display it in GIS a little later in this presentation. Also, if you go the print, you can get a really good print, 300 dpi, 33 inches wide. I mean, it's very high-end print. So back to search. We'll stop looking at EO Browser and we'll say now, okay, let's take this Sentinel-2 and look at it in our Esri GIS, ArcGIS Pro. Now we'll look at the same area that we just viewed in Sentinelhub's EO Browser in ArcGIS Pro. So this bar scale is just from the Sentinel-2 time series. I'll get to that in a little bit. But here we're looking at that same area. You can see we've got an enhanced IR color, so it's very sharp. I've got a color infrared. So this is the virtue of processing, which is what the textbook really discusses. How do you get the most out of your data? Then total IR, which is really interesting. You can see these patterns that we pointed out before showing up the texture. So you look at the different color combinations, you can really pull out, these are different kinds of vegetation. This is a very smooth, dark pattern. This is a very bright red, vigorous. If I look at this, I have even different colors. And then from EO Browser, I downloaded an enhanced color print and then just georeferenced it. And I really like the enhancement that was done on this. See how clearly these striped vegetation types show up, the texture and everything. And these look very similar. Texture, tonal quality, very smooth. And this is the radar. Remember we brought the radar and downloaded it, and I brought it into the GIS so smooth. And so now I can really see, okay, this is where the water is really occurring. I've got a very sharp land-water boundary. I can go into appearance. I click on the radar. I'll swipe, and you can compare the two. You can compare any two images. That's the beauty. So let's compare the enhanced color print with total IR. I have to highlight this. See, image processing, you do it yourself, you see a lot of patterns that tell you a lot of information, even if you've never been to this relatively remote area in West Africa. So what we're going to look at is the living atlas of Esri's ArcGIS. And we've gone to their site. I pulled up the imagery, and in the imagery is the Sentinel-2 10-meter land use land cover time series. And if I click on authoritative only content, this shows up, produced by Impact Observatory, Microsoft, and Esri. So it's a remarkable accomplishment to offer this up, and then a nice detailed discussion on this layer, derived by deep learning AI land classification model, etc., etc., etc. And you can open it in different tools online, or open it in ArcGIS Pro, which is what we'll do here. I've got my portal up. I'm going to filter. I'm going to pick environment and land cover. And up comes that time series. And I've already loaded it into the table of contents, and I'll turn it on. And this is the source resolution is around 1 to 37,000. So we're showing it 1 to 50,000. So we're zoomed out a little bit. You can see it picks up the river very nicely. We've got our classes over here. Flooded vegetation is this lighter green, and trees are the dark green. So let's compare the time cover map. You have this amazing toolbar. We're going back in time. And you can see as the data came in a little differently that the map changes. The most accurate map is supposed to be the newer map. So let's compare the time series. We're up here in the latest map 2023 with one of the images that we processed. You come over here, and all this is flooded vegetation in the map. It does pick up, follow my triangle. That's all I can do when I'm scrolling. It picks up this pattern of the bright green with the texture, and over here it's blended into this pattern over here. We're not seeing differentiation very much. This unit in here, which is very similar to what's over here, is painted as all trees, where the one over here, which is very similar, is flooded vegetation. Let's put another image underneath, total IR. You can see where the algorithm is not classifying what we as humans are saying, I think that this is very similar to what's over here, very similar over here, and we're getting trees mixed up with flooded vegetation. So we'll compare the algorithm derived with one that was done by humans, and you can see the difference. There's a splay pattern that wasn't picked up. It's both the same data, 10-meter Sentinel data, one by an algorithm, and one where you're actually saying, okay, I can see what's on the image, and let me try to make it consistent. So all this orange is dwarf mangrove. The dark area is a tall red mangrove. This is freshwater swamp forest, so it's fresh water. This is grasslands. And there's other classes that we were able to derive from the data set. And you can see how closely, let's say we go to the enhanced IR, how it follows what the eye sees. So be careful when you are using these global cloud-based maps that are based on algorithms that don't necessarily reflect what the ground looks like. A remarkable contribution EO Browser makes is to education with this toggle. So you can see it says, please select the theme. So we go, okay, I'll do floods and droughts. And then you say, well, what about floods and droughts? This doesn't work. You go to highlights, and let's say we want to see drought and up it comes. It's amazing. All this information available instantaneously. We go back to discover floods in Madagascar. Go back to discover, go back to another theme, let's say geology. It's just a great contribution to learn about remote sensing. We're in the Grand Canyon, false color. Geology, it's incredible. The true color penetrating the water. If we go to false color, far less penetration. And if we go to the infrared, short wave, it'll just be black. The shorter wavelengths penetrate the clear water. So I'll leave it at that. Just truly an amazing tool that these people have put together. Slovenia,